Hey guys, I wanted to talk a little bit about population growth, just because we are going to tie it into a little video link about the coronavirus that I just felt was, interesting and would be something kind of current events to bring in here. So honestly, this is an ecology topic. It's usually something I hit right at the end of the year, but I figured we'd get into it now, and it actually does involve one of the major math skills that is on your formula sheet. It's on the back of your formula sheet, and I'll refer to that later. But first, I'm going to go to this paper here, and you can take these notes with me. Going to take a note about population size here. Of this is any wild population, and with unlimited resources, you should see populations grow exponentially. Which a lot of you know is a little growth curve that looks something like this, right? And we'll come back to that. But the first thing I wanted to do here on this paper was to discuss the factors known as limiting factors that make it impossible, really, for wild populations to reach full exponential growth. And so these limiting factors, again, would be things that keep population sizes in check. So in the real world, populations would not grow exponentially. So I'm going to list 1, 2, 3, 4, 5, I believe, around them. We're going to have predation, of course, that is predators. Predation, sorry, I'm already messing this up. That's predators, prey relationships. We're going to have parasitism and disease. And that will limit population sizes. And of course, we are going to have competition. This is just over any resource: shelter, food, water, from protection from predators, all kinds of factors there. Human impact limits the size of real populations. And finally, like climate change, I was going to say natural disasters, but climate and natural disasters limit population sizes. And we can sort of loosely, and I'll say why I may say loosely in a second, loosely divide this into two areas, which would be density dependent limiting factors and density independent limiting factors. What that means is that these three here that we're classifying as density dependent, they get more prevalent and have more of an impact as a population grows in size. So, for example, one easy way to understand this would be competition over food is not very severe if the population is very small. But as that population grows, competition over food gets more severe. In very small populations, we don't really see disease and parasitism taking hold and really affecting the size of the population. But as the populations grow in density and size, we can see those factors really taking over. Now, you could make an argument that human impact is partially density dependent. As animal populations grow, they're more likely to come in contact with humans. So I kind of think of this thing in both ways. But if you think about human impact like man-made climate change, it does not matter the size of your population. Of, let's say, coral. If you're in warming ocean waters, you're going to die. And it doesn't matter how dense your population is. Same thing with something like natural disasters, right? It does not matter if there's one tree on the side of a mountain or 1,000 trees on the side of the mountain. If there is a landslide, all those trees are going to die. So take a moment to distinguish in your mind between density dependent and density independent. And I'll stop this video here. There'll be another one.